This is problem 78 from chapter 16. In this problem, the ring gear A rotates clockwise with an angular velocity of 30 radians per second, while link BC rotates clockwise with an angular velocity of 15 radians per second. We want to determine the angular velocity of gear D. So I have equation 1616, which I can use in this problem. And in order to do this, I'm going to pick a point. I'll call it P, and that point is right here where the teeth of A and D meet. So I'm going to call that point P. So that's there. And then when I use equation 1616, I can say the velocity of point P is equal to the velocity of point C plus my angular velocity crossed with my vector which points to P from C. And this angular velocity here would be the angular velocity of gear D. So now I need to know the velocity of point P and also the velocity of point C. Well, they give me angular velocity BC and the angular velocity of A, so I should be able to do that. So if you say this point P here is on one of the teeth from gear A, which is right here, gear A is rotating this way. So the velocity of point P would be in the positive x direction. And we have the angular velocity here and the distance from point B to where the teeth are on gear A. So the velocity of point P is equal to the angular velocity of 30 radians per second times the distance here, which is 300 millimeters, and that's going in the I hat direction. And if we change this to meters per second, we get 9 meters per second in the I hat direction. Then for the velocity of point C, we know this angular velocity here, that is 15 radians per second. The distance from point B to that point C is 250, that's shown there, millimeters. And if the angular velocity is clockwise, which is this way, point C will be moving in the positive I hat direction also, and in meters per second, this gives us 3.75. Okay, so finally, for my equation up here, this is supposed to be an R. I need the position of P going from point C. So point P is here, this is point C, so that vector is pointing this way. And that's the J hat direction, and if this distance is 300 and this distance is 250, then the length of that vector is 50 millimeters. So that's 50 millimeters going in the J hat direction. So now I can write this equation again. VP is 9 meters per second. The I hat direction, VC, is 3.75 meters per second, also in the I hat direction. I need to know something about the direction of the angular velocity. So it's either in the positive k hat direction or the negative k hat direction. So let's just say omega d is the z component in the k hat direction, and this component can be positive or negative. So when I do the cross product, it is the angular velocity crossed with the position vector, which is in the j hat direction. So let's just do this down here. Crossed with this, that would be k hat crossed with j hat, omega d k hat crossed with 50 millimeters in the j hat direction. And so k hat crossed with j hat gives me negative I hat. So this is, from our equation here, the cross product is omega d times 5 millimeters in the negative I hat direction. Okay, so we have one equation here, and since the only non-zero components in this equation are the I hat components, we can use this equation to find just one unknown, but we only have one unknown that we're looking for. So omega d becomes, I can bring the 3.75 over to the other side, and that's 9 meters per second minus 3.75 meters per second divided by negative, let's change this to meters, so that's 0.05 meters, and I get omega d is equal to, this is negative 105 radians per second. If we write it as a vector, we have this. So this means since it's negative, it is going in the clockwise direction. And that is problem 78.